In this video, we talk about a couple of techniques that are used to share a channel. For example, if you got a piece of copper like the cable and you need to send a lot of different signals on the cable, but you want to keep them separate, or you're using, I don't know, air, and you're trying to send a lot of signals on the air at the same time, or effectively at the same time, we either use what is called the frequency division process, or we use a time division process. Let's go ahead and start with the frequency division first, and then we'll come back later on and we'll talk about the time division. What, as the name implies, frequency division basically takes the frequency spectrum, if this is the omega, and divides it into pieces and shares it across different signals. So let's say there is an omega C1, omega C2, omega C3, and then depending on how big the signal is, allocates a certain band to them, and that's basically called frequency division. And since in electromagnetic environment, when we send a signal with a given frequency, it doesn't matter if it is in the same medium, it's never going to mix up. You can always take it back out using filters. So, here are some examples. For example, if I want to send x1 of t, let's say, and I want to send it, and let's say the maximum for x1 of t, the maximum signal is omega m1, I allocate a carrier, omega c1, to give me a center frequency, and this is the band I'm going to transmit that signal in. And at the same time, I might have an omega c or omega n, each one at a different center frequency. So they're going to be modulated to different parts of the frequency spectrum across the x-axis. Then I'm going to mix them together in a medium like a cable, a coaxial cable, copper cable, or just simply air, and then I'll send it on the receiving end. I know for example, if I want to recover a particular signal, I will just basically want to put a bandpass filter, just picks up this omega c1 plus omega m and minus omega m. So I'm just going to pick up this little piece, and that becomes my the filter it. Then I can multiply it to the carrier to bring it back to its original location, and then pass it through a low pass filter and get my original signal back. And I can do that with every one of those. So as you can see in this particular case, what we're doing, we're taking the frequency spectrum available. Spectrum is a fancy word of saying the frequency range available to us, and we'll break it and give each signal in its own piece, and then we use a cosine of omega ct to move it to that location, and then when we get to the other end, we use omega ct to get it back. Now, so that's pretty much it. Now you got to be careful that omega c1s are far enough apart, far enough apart such that omega m from one signal doesn't interfere with the other signal and things like that. But those we do. For example, when you're listening on the radio and you're listening on 91.5 radio station, that is its center frequency, and right next to it there is probably going to be 97, which is another radio station, but we know each one of those are sending human voices, which means the omega m for the thing is only 20 kilohertz, so there's plenty of space to spread out without worrying about these edges connecting to each other. So that's called the frequency division process for sharing a medium. Another way to shares the same medium is through time, and that's more understandable. So if this is the time axis, one signal gets to go from point t0 to t1, another signal gets to go from t1 to t2. So x1 is sent here, x2 is sent here, and x3 is sent during this period. And that's common sense, if it makes sense. So everybody take turn sending the signal over the same wire, but there's only one signal being sent at the same time. And that's called time division multiplexing. And so one example of this is very much used in computer networks. For example, if you have a LAN in your place, that's exactly how that is done. or even if it's wireless, they still do time multiplexing for that purposes. But if you're looking at TV over a coaxial cable or radio over a coaxial cable, they're using frequency division multiplication. These are just simple examples of it. These are applied to variety of application across the industry. So TDM, or the time domain division multiplexing, is where the time axis is taken. So this would be TDM, time domain multiplexing, and this is basically frequency division multiplexing. And you basically take the frequency spectrum and divide it up. That brings us to the end of this video.